Hey everyone, Hihu here from LeetCode. Today we are solving LeetCode 1431, Kids with the Greatest Number of Candies, using Java. This is an easy difficulty problem, and it comes under the Arrays section of the LeetCode 75 study plan. And to be honest, the title already tells us quite a bit about what we are going to be working with. We have got kids, we have got candies, and somehow we need to figure out which kids can end up with the greatest number of candies. Let us find out how. Now that we know what we are dealing with, let us take a look at the problem statement. We are given an integer array called candies. Each element in this array represents the number of candies a particular kid currently has. We are also given another integer called extraCandies. Now here is the important part. For each kid, we can imagine giving all of these extra candies to that kid. And our task is to determine whether that kid can end up having the greatest number of candies among all the kids. If they can, we will return true for that kid. Otherwise, we will return false. And after checking every kid, we will return the complete list of true and false values. Now that might sound a little abstract when we hear it for the first time. So instead of staring at the problem statement, let us work through an example and see exactly what is happening. Let us understand this with an example. Suppose we are given candies equals 23513 and extraCandies equals 3. Now instead of looking at these as numbers, let us imagine 5 kids standing in a line. The first kid has 2 candies. The second kid has 3 candies. The third kid has 5 candies. The fourth kid has 1 candy. And the fifth kid has 3 candies. Now before we do anything else, can you spot who currently has the most candies? Exactly, the third kid. With 5 candies. At the moment, that is the tallest candy tower. Now remember, we are also given 3 extra candies. And here is the interesting part. We are not distributing these candies among all the kids. Instead, we are going to imagine giving all 3 extra candies to one kid at a time. Let us start with the first kid. The first kid currently has 2 candies. If we give them all 3 extra candies, 2 plus 3 equals 5. Now this kid also has 5 candies. So can this kid have the greatest number of candies? Yes. Because they have reached the same height as the current tallest tower. So for this kid, our answer will be true. Now let us try the second kid. They have 3 candies. Give them all 3 extra candies. 3 plus 3 equals 6. Now they have even more candies than the current leader. So this one is also true. Now let us look at the fourth kid. They only have 1 candy. After receiving the extra candies, 1 plus 3 equals 4. But the tallest tower is still 5. So even after getting all the extra candies, this kid still cannot catch up. That means the answer for this kid is false. And that is really the question we are answering for every kid. If we give all the extra candies to this kid, can they reach or exceed the current highest candy count? Once we answer that for every kid, we will have our final result. Now that we have a clear picture of the problem, let us think about how we might solve it. And as always, we will start with the most straightforward approach first. So if you were solving this problem for the very first time in an interview, what would be the most natural thing to do? Well, for each kid, we need to know whether they can have the greatest number of candies after receiving the extra candies. So let us focus on just one kid for a moment. Suppose we are looking at the first kid. We give them all the extra candies. Now we have their new candy count. But how do we know if that is enough? Well, one obvious way would be to compare their new candy count with every other kid. If nobody has more candies, then this kid can have the greatest number of candies. Otherwise they cannot. Sounds reasonable, right? Now we can apply the exact same logic to every kid in the array. For each kid, give them the extra candies, compare their new candy count with every other kid. If nobody has more candies, store true. Otherwise, store false. It is a simple approach. It does not require any special observations. And most importantly, it gives us the correct answer. Now let us see how we would actually implement this idea in code. Now that we have the idea, let us see how we would implement it. We will start by creating an empty answer list. This list will store our true and false values. Next, we will iterate through every kid in the array. For each kid, we will calculate their new candy count after receiving the extra candies. Then we will compare this value with every other kid in the array. If we find even one kid with more candies, we know this kid cannot have the greatest number of candies. Otherwise, they can. Once we have checked all kids, we will add the result to our answer list. And after processing every kid, we will return the final list. The implementation is pretty straightforward. But notice something. We have ended up using two loops. One loop to pick a kid, and another loop to compare against all kids. Let us see what this actually looks like during execution. Now that we have the brute force solution, let us run it on our example, and see exactly what is happening. We will use candies equals 23513 and extraCandies equals 3. We will also start with an empty answer list. Our outer loop starts with the first kid. The first kid has 2 candies. After giving this kid the extraCandies, they now have 5 candies. Now we compare this value with every other kid. Since nobody has more than 5 candies, we add true to our result. Next, we move to the second kid. After receiving the extraCandies, they now have 6 candies. Again, nobody has more than 6 candies. So we add another true. Now let us jump to the fourth kid, because something different happens here. The fourth kid has only 1 candy. After receiving the extraCandies, they have 4 candies. As soon as we compare this with the kid who has 5 candies, we know this kid cannot have the greatest number of candies. So we add false. The same process continues for the remaining kids. And once both loops finish executing, our final answer becomes true, 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 false, true. So the brute force solution gives us the correct answer. Now whenever we come up with a working solution, the next question we should ask is, how efficient is it? Let us analyze the complexity and find out. So how efficient is this approach? For every kid in the array, we are running another loop to compare against all the other kids. If there are n kids, the outer loop runs n times. And for each iteration of the outer loop, the inner loop can also run up to n times. That gives us a time complexity of O(n) squared. The space complexity is O(n) because we are storing the final answer list. Now let us think about what we are actually doing here. For every kid, we are scanning through the entire array again to compare their candy count with everyone else. That feels like a lot of repeated work. So the next question is, can we somehow avoid those repeated comparisons? Let us take a closer look. So the brute force solution works. But its time complexity is O(n) squared. And the main reason for that is our inner loop. For every kid, we are scanning through the entire array again to compare their candy count with everyone else. Now let us think about what we are actually doing in those comparisons. When we checked whether a kid could have the greatest number of candies, were we really interested in every value in the array? Or were we ultimately trying to compare against the kid who currently has the most candies? Because if that is all we care about, maybe we do not need all those comparisons after all. Let us see how that observation can help us build a better solution. Let us go back to our example. The greatest candy count in the array is 5. Now suppose we are checking the first kid. After receiving the extraCandies, they have 5 candies. Do we really need to compare that against every other kid? Not really. The only value that matters is the greatest candy count currently present in the array. Once we know that value, everything becomes much simpler. For the first kid, 2 plus 3 equals 5. Can 5 reach the current greatest candy count of 5? Yes, so the answer is true. For the fourth kid, 1 plus 3 equals 4. Can 4 reach 5? No. So the answer is false. Notice what has changed. We are no longer comparing against every kid. We are only comparing against one value, the maximum candy count in the array. So our new approach becomes: first, find the maximum number of candies in the array. Then, for each kid, add the extraCandies. If the result is greater than or equal to the maximum, store true. Otherwise, store false. And just like that, we have eliminated the need for the inner loop completely. Now that we have the key observation, the implementation becomes much simpler. We will start by finding the maximum number of candies present in the array. One way to do that is by iterating through the array and keeping track of the largest value we have seen so far. Once this loop finishes, maxCandies will store the greatest number of candies currently present in the array. Next, we will create our result list. Now we will iterate through each kid in the array. For every kid, we will calculate how many candies they would have after receiving all the extraCandies. Then we will simply check whether that value is greater than or equal to maxCandies. If it is, we add true to our result list. Otherwise, we add false. And finally, we return the result list. Notice how we completely got rid of the inner loop from our brute force solution. We are only comparing against the maximum candy count. Now that we understand the code, let us run it on our example and see it in action. Now that we understand the code, let us do a quick dry run and see it in action. We will use the same example. The first thing our solution does is find the maximum value in the array. We start with the first candy count, which is 2, so our maximum becomes 2. Next we look at 3. Since 3 is greater than 2, we update our maximum to 3. Then we look at 5, again. That is larger than our current maximum, so we update it to 5. The remaining values are 1 and 3. Neither of them is greater than 5. So after the first loop finishes, our maximum candy count is 5. Now we move to the second part of the solution, where we build our answer list. The first kid has 2 candies. After receiving the extra candies, they would have 5 candies in total. Since 5 is greater than or equal to 5, we add true. The second kid would have 6 candies. So we add true. The third kid would have 8 candies. So we add true. The fourth kid would have only 4 candies. Since 4 is less than 5, we add false. And finally, the fifth kid would have 6 candies. So we add true. Our final result becomes true, 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 false, true, which matches the expected output. Now let us analyze the complexity of this solution. The first loop is used to find the maximum candy count in the array. This takes on time. The second loop is used to build our answer list. This also takes on time. So the total time complexity becomes on. The space complexity is on, because we are storing the final answer list. Compared to our brute force solution, we have improved the time complexity from on squared to on. A pretty nice improvement for such a simple observation. Now before we wrap up, let us quickly recap the solution. Let us quickly recap. Step 1. Find the maximum candy count in the array. Step 2. For each kid, check whether candy plus extra candies is greater than or equal to max candies. Step 3. Add the result to the answer list and return it. Simple. Efficient. And that is all it takes to solve this problem in on time. And that is all it takes to solve LeetCode 1431, Kids with the Greatest Number of Candies. If you found this explanation helpful, make sure to like the video and subscribe to LeetCode. Also let me know in the comments which LeetCode problem you would like me to cover next. Thanks for watching. This is Hugh, signing off. Keep practicing, and I will see you in the next one.